An airport purchases an insurance policy to offset costs associated with snowfall. For every full 10 inches of snow in excess of 40 inches, the insurer pays the airport 300 up to a policy maximum of 700. The following table shows the probability function for random variable x of n of annual snowfall in inches. Okay, calculate the standard deviation of the amount paid under the policy. So the payment is paid only when you go full 10 inches in excess of 40. So 10 inches in excess of 40 means 50. So it means that payment only starts after 50. So there is no payment up to this range because all this is less than 50. So we can combine these four intervals into one and say that as long as the rainfall is between 0 and 50 inches, the probability of that is you add these four probabilities and the payment for this amount of rainfall is 0. So these four can be lumped together into a total probability. So let's add these 0.06, 0.18, 0.26 plus 0.22. That gives you a total of 0.72. So we can say that the probability is 0.72 that the rainfall will be between 0 and 50 inches, and the payment for that will be 0. So next we'll be making a column, a table which also includes the payment. So like here, so 0 to 50 is being lumped together. Total probability is 0.72. Like I said, add the first four corresponding to this, and that payment is 0. And now when you are between 50 and 60 inches, you are 10 up to less than 20 inches. So remember, the payment is only done for full 10 inches. So this is the first time you exceed 10 inches in this interval, but you're not going to hit 20. So you'll be paid 300. So this 0.14 was the probability of this interval, the 50 to 60, if you look in the table above. And the payment for that will be 300 because you're full 10 inches and some, but less than 20. When you are in this interval now, you hit the 20 inches. And so there'll be an extra 300 in addition to the first 300. So that'd be a total of 600. And the probability of that interval was 0.06. But then when you hit the next 10 inches, remember the cap is 700. Maximum payment is 700. So now you don't get another 300, but you're just stopping at 700. And similarly, even when you're here, you get 700. Now there was one more interval which said 90 to infinity. There also the payment will be 700, but they were mentioning that the probability of that is 0. The probability of that was 0. So since that's never going to happen, so they may well have just omitted this entry. So now also note here that since the 70 to 80 and 80 to 90, they both have the same payment of 700. So we could have lumped these two intervals together into a 70 to 90 interval with a probability of 0.04 plus 0.04 equals 0.08 and a payment of 700. And then finally note that if you are doing the standard deviation, which is what we have to calculate, the standard deviation of the payment, standard deviation of the amount paid. If you were to do the standard deviation by hand, like by calculating expected value of x and expected value of x squared using the usual formula, then you could even have omitted this 0 payment entry, and you could have just considered these three, because this one is not going to contribute anything either to the expected value of x or to the expected value of x squared. But when you do on calculator, you have to include it, because remember, on calculator, in order to do the standard deviation, the probabilities must be adding to 1. So you must have the full probability distribution in order to get the standard deviation correctly from the calculator, which is what I'm going to do. And remember, this is my first column, the payment, because I'm calculating the expected value of the payment. So in fact, let's do it. So the first column will be 0, 300, 600, 700, 700. So remember, we do data and we clear data. Hit data again, clear, and then hit data again, scroll to number 2, clear. So now everything is being cleared. And so our payment entries were 0, enter, 300. So you could either scroll down or you could enter. Maybe enter is a bit faster. 300, and then it was 600, and then it was 700. And actually, let's lump it together, as I was saying, that you could lump the last two together and under a probability of 0.08. Okay, and then the probabilities were 0.72, 1406, and these two, we are combining these two into a 0.08. 0.72, 0.14, 0.06, 0.08. And actually, all of them can also be multiplied by 100, since probabilities are just weights. So as long as you maintain the same relative magnitude of them, that's fine. So I would do 72, 14, 6, and 8. 72, 14, 6, and 8. And then I do second stats and enter, 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 enter. And remember, we're looking in probability distribution only. We're always looking for population standard deviation, not the sample one. So sigma x is 235. And that is the answer, 235. And that was choice B.